My name is Sebastian Götz, and I want to shortly summarize you our paper entitled Model-Driven Software Engineering for Construction Engineering, Quo Vadis. What motivated us to write this paper? Well, we had a research project with people from the construction engineering domain, so we started to investigate how models are used in this area. And we found out pretty fast that models are an inherent part of this domain and that they actually have several, mature approaches on handling their models. Namely, they have so-called building information modeling, which denotes a complex initiative, I would say, starting from the simple drawings they had in the past, so CAD drawings, to really come up with semantically rich models and the integration of multiple models and all aspects of model management involved. They have additionally the so-called integrated process delivery, which is another initiative going besides BIM into issues of model management to improve the communication between the individual stakeholders of construction projects. As the main underlying principle, we can see lean construction, where they focus on minimize waste, increase value, and continuous improvement. And well, that is of course only possible if you use models and if you use models in a good way. So applying model-driven software engineering techniques to this domain is a total natural choice. What we surprisingly found out is that there is not yet any state-of-the-art overview for model-driven software engineering in this area. So we made one. The research questions we aim to answer in our paper are threefold, so we have three of them. The first asks where the discourse on MDSE for BIM, IPD, and lean construction currently is. The second asks for the model-driven techniques which are already applied. And the third one asks for those model-driven techniques which should be applied in the future. Before we dig into the answers to these three questions, let's have a short look at our method. We actually followed a systematic literature review process as introduced by Barbara Kitchenham, which is only slightly adjusted. So at the beginning, we added a pre-study because we started by reading around about 60 papers to get into the topic at all, so we know about the keywords and get ourselves familiar with the topic. You see in the numbers at the bottom of this figure that we started our search with an initial list of almost 7,000 papers, which we then filtered by title and type, and by reading the abstracts, applying in and exclusion criteria, ended up with 97 papers in total, which are included in our paper. We also came up with a taxonomy, as you will see shortly. But let's first answer research question 1. Where is the scientific discourse currently? We found out that 50 of our 97 papers we included are in forms of construction engineering, and that the 46 other papers are also in, general engineering and AEC, so architecture, engineering and construction related forums. Only one paper was really published at a model-driven software engineering conference. And that was actually at ICMT, and it wasn't written by construction engineers, but by software engineers. So we can conclude that the discourse is not yet in our forums, but in the forums of engineering. To answer research question 2, which model-driven techniques are actually already applied, we came up with this taxonomy. This taxonomy gives you an overview first in 3.1 on the currently applied technologies, which span the standards by industry, so like the building smart standards, industry foundation classes, and so on, or the STEP format, standard for the exchange of product model data, going until, well, technologies like OWL and Modelica. For details, just have a look at the paper. There you get nice summaries of what these individual things here all mean. More important for research question 2 is 3.2, namely the modeling techniques used. So we've seen quite a couple of them, most prominently model transformations, of course, but also merging models, traceability in models, and many more. Again, I refer you to the paper to read about the details on how these techniques have actually been used, but here is the list, at least for you to get the insight how many techniques have already been applied in construction engineering. In 3.3, we investigated the meta level, which has been used in the approaches presented, so in the papers we surveyed. We did this to figure out how abstract actually the works are. So do they introduce only models? Do they talk about meta models, or do they even talk about meta languages on M3? Our finding was a bit subtle, because what we found out is that construction engineers often have misunderstandings about the meta-level pyramid. So they often are not very clear about the level they are on and sometimes mix up concepts. Again, I refer you to the later paper for more details on this issue. Finally, we investigated different interfacing research areas to find out which other areas are of importance to this topic, and not very surprisingly, we found out business processes, data warehousing, cloud engineering, and knowledge engineering as those which interface here. And finally, application domain. These are kind of domains where case studies have been conducted. And here we see facility management and simulations as the most prominent examples. Let's have now finally a look at the research question 3, which is the list of research gaps. So where can we actually further dig into research? And we identified 4 main areas which definitely need further research, but this list is of course not exclusive. So of course domain-specific modeling languages, model validation, and all the other subdisciplines which are not listed here are very important too. But let's go through those 4 main things we identified. First, we talk about multi-paradigm modeling, because if you look at a construction project, you will see that many different disciplines have to work together here. Yeah, think about the statics, fluid dynamics, heating, ventilation, air conditioning, fire protection. So there are many different types of models which need to be integrated and which need to work together, which is of course subject to multi-paradigm modeling. Also, and that holds for the next 2 clusters, those models you make for buildings or constructions, they are very long-lasting, because they are made not just for construction but also for facility management until the destruction of the building. So they need to last, let's say, 10, 20 and more years. So they of course need to evolve, so we need techniques from model evolution, and they are updated frequently, so we also need models at runtime. Finally, and that is very interesting to see, multi-level modeling is a promising area of research for building information modeling, because if you look into the industry foundation classes, which are the de facto standard in this area, they already have related concepts like IFC type objects and IFC property sets. So here further research is definitely welcome and needed. So if you want to get more details, please read the paper. You will find it in a special issue of JOT. And if you want to get the data, the raw data we had in our survey, you can find it on GitHub, which I will link down in the video description. Thank you and goodbye.